Let's learn about recursion. Recursion is a type of algorithm where we break down a problem down into subsets of the same problem and then solve the simplest version of the problem and then apply the solution to each of the subset of the problem. Okay, so let me just explain it to you. So if you have a big problem here, what maybe if you want to sort a box which has 100 books. Okay, so for that what you do is you break down it into two. You say that okay, you break down it into 50 bunches of 50. Then you again break down it into 25 boxes of 25 or sets of 25. Okay, you just take 25 and then break down into multiple levels, saying that you have only two books here. Now sorting these two books is pretty easy. Okay, so you sort these two books in the normal way, and then you take that to the next level, because every branch, so here there will be one branch and here there will be another branch of two books. So you sort this one and this one will be a branch of four. So you just sort the lowest level of the branch and then you build that up upstairs on the top ones, and then you take it to the highest level, and then the final one will be sorted. Okay, so this method is called recursion. So in programming, the recursion, how do we implement recursion is by means of functions. So what you do is you write a function, and then within the function you call the same function with a different value. Okay, then you do some manipulation. It's not that enough. You will have to do some more manipulation, and then you will get the final results. Okay, so let me tell you one example. So if you have an iterative approach means you just start from the top, go into the begin. Okay, so suppose if you have to search 100 boxes in a room for a key. Okay, then another scenario, search 100 boxes in a room for a key. So in an iterative approach, what you do is you first make a pile of boxes, and while the pile exists, you grab a box, check for key, and then if there is key, you end the process, else you continue, else till the pile exists you just continue. So this is the iterative approach. But when it comes to recursive approach, what you do is you might have a function called search, and inside that you will have search, grab a box, check for key, same, if there is a key, end the process, else go and search again. So again you are calling the same function, so that it repeats it again. Okay, so this is the recursive mode. So what happens is this becomes easier because programmatically this becomes easier because you need to write very less number of code, and it is more efficient also. Okay, so where do we use this recursion? So recursion is used when you have to find sum of n numbers. You have to find the sum of n numbers. What you can do is you can call a function. So sum of n, the function call will be sum of n is equal to n plus sum of n minus 1. So how does it work is if you want to find the sum of maybe five numbers, okay, so 1 2 3 4 5, these are the five numbers, so maybe it is 10 20 30 40 and 50. So what you are doing is you are adding a 5 plus the sum of the other four numbers, and then that repeats itself so that you get the final number. Again, you have to put a condition also. Okay, if the number is less than 0 or something like that, then you have to put a condition. That's a different thing altogether. Same with factorial. So factorial n is equal to n times factorial n minus 1. So factorial means it is multiplication. So it is factorial equal to n times n minus 1. Okay. So another use case of recursion is Fibonacci series. Fibonacci series means a number is a sum of the previous two numbers. So Fibonacci series, Fibonacci of x is equal to Fibonacci x minus 1 plus Fibonacci of x minus 2. So it's a sum of the previous two numbers. So that is what you use it for Fibonacci 1. Okay, so let me just give you one programmatic example of recursion. So I'll take the factorial. So how I do is the definition of factorial, which is n, and I will put the condition if n is equal to 0, because you have to put a exit condition, then return 1, else return n times factorial n minus 1. Okay, now there's a practical example of recursion, which is to find the spread of spread of infectious diseases. So whenever you need to find a spread of infectious diseases, you find usually what they do is like they do recursion. So it is like patient 0, and then they will have patient 1, patient 2, etc., and then that process continues. So this will be the first person who is infected, and then they do the same process for multiple patients.